All right, so the solution, you can just use any pencil or pen that you have, of an equation is the value of the variable or variables that make the equation a true statement. Equations in one variable have either one solution, infinite solutions, or no solution. Okay, and how these color codes are going to go is one solution information is going to be in blue. Infinite solutions are going to be in green. And no solutions are going to be in red. Okay, so for one solution, the reasoning, what the type of solution means with your blue pencil, only one value will make the equation true. Only one number will work. Only one value will make the equation true. In other words, only one number will work for the variable. For infinite solutions, any value will make the equation true. That means any number. Any number in place of the variable will work. Okay, and on our final reasoning for no solution, no values will make the equation true. So no numbers will work in place of the variable. None of them. Okay, so let's talk about if it has a true solution, always, sometimes, or never. So if you have an equation that has one solution, okay, think about all of the numbers. Will they always, sometimes, or never be true? If you were just guessing and checking, only one number would work, right? So sometimes. If you happen to use that number, it'll work. But if you use any other numbers, it's not going to work, right? So a conditional equation is true for some values of x. Only true one time. It is only true one time. And that's whatever that number needs to be for x. Okay, with your green pencil. If it's infinite solutions, okay, how many times will you get a true solution? Always. It will always be true. So no matter what you put in for that variable, it will work. So an identity is always true for any value of x. So it's true every time. And finally, for no solution, what would that one be? It's never true. So a contradiction is never true for any value of x. So not ever true. Okay. Now, let's look at some examples. Let's start with our one solution example. So switch back to your blue pencil. Okay, so we have 4x plus 6 equals 18. I don't have distributive property. I don't need to combine like terms. Do I need to move my variable to one side? I don't need to move my variable one side. It's already on this side by itself. So now we need to move the constant. When I move that constant, I'm going to add 6 to both sides, right? So put it directly under the 6 and directly under the 18. Oh, sorry. Subtract. Thank you. I'm going to subtract 6 from both sides. So when I subtract 6, these cancel. 18 minus 6 is how much? So bring 12 down, equals, and what's left over here comes down. So 4x equals 12. And to isolate the variable, what do I need to do? Divide by the coefficient that's with x, right? So divide by 4. When I divide by 4, 4 divided by 4 is 1, and that leaves me x. And 12 divided by 4 is 3. So blank is the only number that makes the equation true. What number? 3. 3 is the only one that will work. Okay, so next with our green pencil, if we look at this using our flow chart, there is no distributive property or combining like terms. Are my variables the same? Yes. Are my constants the same? Yes. And using our flow chart method, we know that it would be infinite solutions, right? Okay, but let's say that we're solving it, just solving it all the way through. Our next step would be to get the variable on one side, right? So what's the inverse of 5x? Yeah, minus 5x or negative 5x. So show that. Those are exact opposites on both sides, so they both go away. What's left? 15 equals 15. Well, is that true? Yes, this is true. Okay, and if it's true that 15 equals 15, that's infinite solutions, so what numbers are going to work for x? Any number. Any number will work. Any number will work for x. Okay, and our next example for no solution, so use your red pencil. We need to get our variable on one side, so I'm going to do the opposite of 4x and put negative 4x, right? But when I do that, they both cancel because they're both exact opposites. So what am I left with? 8 equals 3. Does 8 equal 3? No, put a slash to the equal sign. They do not equal each other. Okay, so this is false. And if it's false, how many numbers will work, or what numbers will work for x? No number will work. No numbers work for x. Okay, let's fill out this very bottom part. Looking for hints. It says, look at both sides of the equation. So for this one, the end result still has, what does it still have? Whenever we solve this and it has one solution. It still has a variable, doesn't it? So still has a variable. You can use your pencil for this one. It still has a variable and a solution. If you're looking at an infinite solutions equation, variables cancel each other out and both sides of the equation are what? They both look equal. Okay, and finally, with no solution, the variables cancel out and both sides of the equation, they're not equal, do not look equal.